Welcome back to the Explainer. If you're prepping for the AB 100 exam, you already know the design questions are, well, they're brutal. They don't just care about what a feature does, they want to know if you can actually think like a lead architect. Today, we are focusing heavily on the critical pillars of security, identity, and compliance. And to get you ready, we're bringing you the ultimate cheat code, the Govern Global case study. Govern Global's journey in building out their enterprise AI architecture is essentially a masterclass in exactly how to pass this exam. Let's jump in. So here's the harsh reality that catches so many people totally off guard. A brilliantly designed AI agent is absolutely, literally useless if it violates compliance. On the exam, they're going to throw options at you that sound amazing, super innovative, incredibly fast, but they are functionally dead on arrival because they break governance rules. In this explainer, we're going to dissect the near misses. We'll look at the rejected designs proposed by developers and the ultimate corrections made by Govern Global's lead architects, Supra and Azure. Figuring out exactly why an architect says no is your secret weapon for anticipating the principles the exam is going to test you on. Think of this as your syllabus for success today. We're going to master 4 core domains. First up, orchestration dependencies. Second, NLU determinism. Third, the absolutely crucial difference between guardrails and behavior envelopes. And finally, memory state and sprint scope. Master these 4, and you are going to crush the design portion of the exam. All right, Section 1, Orchestration Dependencies, or, as I like to call it, the illusion of speed. Picture this scenario. You've got a developer building a field service routing agent. They want one single agent to grab technician availability from a basic operational system and then pull patient visit data from a protected health information or PHI system. The developer wants speed, they want simplicity. But as Supra, the Govern Global architect, quickly pointed out, one agent accessing both PHI and operational data collapses the security boundary. Think about it. The moment you let one agent touch everything, even a mundane question like, hey, who's working tomorrow, suddenly triggers a strict HIPAA audit trail, just because that agent also has the keys to the PHI. It's a total compliance nightmare. The fix? You separate them. You create one operational agent and one PHI scoped agent. But the second you have 2 separate agents, you have to orchestrate them. And that brings us to a major exam decision point, sequential or parallel. Whenever you face an orchestration question on the exam, I need you to forget about speed for a second. Ignore it entirely. Instead, ask yourself this one golden rule question. Does this step require the output of the previous step to begin? Your answer to this dependency analysis dictates your entire architecture. Let's actually apply that golden rule to the Govern Global Claims pipeline. The process flows like this. Step 1, extract the claim. Step 2, translate it. Step 3, validate it against a schema. And Step 4, route it to an adjudicator. Now, can you translate the claim before you even extract the text? No way. Can you validate it against a schema before it's translated into English? Also no. Every single step fundamentally depends on the completion of the step right before it. This is the textbook definition of sequential orchestration. If Step 1 fails, the whole pipeline just halts. Now contrast that sequential pipeline with the field service routing agent we were just talking about. Retrieving technician availability from Dynamics 365 and retrieving patient location from the PHI system, those are completely independent tasks. One does not need the other to begin. Therefore, they're orchestrated in parallel. In sequential orchestration, the total time is the sum of all the steps. In parallel, the total time is only as long as the single slowest step. But, and this is a huge but for the exam, remember that parallel is chosen because of that independence. The fact that it's faster, that's just a happy side effect. It is not the architectural reason for the choice. Moving right along to Section 2, NLU determinism and surviving the government audit. Govern Global was tasked with building an AI assistant to help caseworkers look up eligibility rules for a government agency. Sounds pretty straightforward, right? Until the legal team gets involved and lays a massive trap for overeager developers. Their strict requirement was this. Every single response the AI system gives must be provably identical across all users, all sessions, and all future system versions. On the exam, this scenario is a classic trap. They're absolutely going to try to trick you into choosing generative NLU because it's modern, it's highly capable, and it's fast to build. But generative NLU is probabilistic by nature. Even if it gives a fantastic answer, it simply cannot guarantee a provably identical answer every single time. So a super common compromise developers try to make here is saying, well, hey, let's just use generative NLU, but crank the model temperature down to 0.0. Sounds logical, right? But as Anna correctly flagged during the build, temperature 0.0 does not create true determinism. It just means greedy sampling. It's just picking the highest probability token. The output is still totally at the mercy of minor input phrasing changes or future model version updates. If a citizen asks the exact same question a year from now after a back-end model update, the answer might be slightly different. And in a strict government audit, that is a complete failure. For a strict audit scenario like that, standard NLU is completely non-negotiable. With standard NLU, the model isn't generating the answer on the fly. An intent classifier simply routes the user to a specific human-authored dialogue tree node. It is highly deterministic. When the auditor asks what the system told a citizen on March 15th, you don't hand them a probability score. You give them the exact authored response at node 42, version 1.3, approved on January 8th. Generative NLU is amazing for customer service, where flexibility is the goal. But for legal determinism, standard NLU is your only valid choice. Section 3. Guardrails versus behavior envelopes. This is the security climax of the exam prep. Let's look at a case management agent designed by a developer named Sood. It summarized case files, it had safety guardrails, and it used an approve button for the human officer to click. It almost bypassed genuine human review entirely. But Supra dropped this absolute mic drop quote during the design review. An approve button the officer clicks automatically is not a human-in-the-loop checkpoint. If the workflow is designed so that the human can just blindly click approve without actually reading the output, the governance is a mirage. Real governance is about genuine human enforcement, not just slapping UI buttons on a screen to check a box. And this brilliantly illustrates the critical difference between these two security layers. Content safety guardrails control what the agent can say. They filter out toxic content, they stop PII from leaking, and they block prohibited topics. Behavior envelopes, on the other hand, control what the agent can do. They define the agent's action scope, like strictly restricting its ability to write an outcome directly to a database without proper authorization. You absolutely need both, and here's why. An agent can politely, safely, and non-toxically execute a completely unauthorized action. If it outputs, "I have summarized this case and cheerfully approved the payment," that sentence passes every single content safety guardrail with flying colors. Only a behavior envelope prevents the agent from actually having the right access to the payment system in the first place. And remember, that envelope only holds up if the human-in-the-loop checkpoint is strictly enforced. Finally, Section 4, Memory State and Sprint Scope. This is the reality check. This is where we look at how Govern Global manages their data retention and how they set real boundaries on what they actually build during a project sprint. Let's talk about memory first. Govern Global's patient intake agent handles highly sensitive PHI conversations. Supra made the call to use ephemeral memory. This means the memory only exists for the exact duration of the session and is securely discarded immediately after use. It's the gold standard for data minimization. If you choose persistent memory, which survives across multiple sessions, you instantly trigger massive compliance overhead. Suddenly, you need data retention policies, explicit user consent, and incredibly complex access controls. For PHI, unless you absolutely need historical context, ephemeral memory keeps your compliance perfectly clean and simple. And speaking of keeping things simple, let's talk about project scope. Overscoping is a massive trap in enterprise AI, and they will test you on this. There is a famous case study of a logistics company that tried to build 7 specialized agents simultaneously in their very first sprint. Guess what happened? Inter-agent communication completely failed. They spent all their time debugging orchestration complexity instead of building actual business functionality. After 6 grueling months, they had to abandon the project and start completely over from scratch. So how many agents did Abi, the delivery manager, approve for Govern Global Sprint 1? Exactly 1. The HR policy agent. That's it. Scope management isn't about moving slowly. It's about building a rock-solid foundation. You build one agent, you deploy it, you establish your security patterns, identity access, and governance, and then you use that proven foundation to make every subsequent agent faster, cheaper, and way lower risk. All right, if you're taking notes, go ahead and screenshot this summary right now. This maps directly to the AB100 design exam questions we've covered today. If a question is about orchestration, immediately look for dependency analysis. For NLU type, watch out for strict audit needs pointing you straight to standard NLU. For security, just remember, guardrails dictate what an agent can say, while envelopes dictate what it can do. And for memory, ephemeral is your absolute go-to for PHI data minimization. So the crucial takeaway here is that enterprise architecture is about deliberate, defensible choices. I'm going to leave you with this provocative thought to chew on. When you sit down to design your next AI agent, are you just optimizing for speed, or are you actually optimizing for the dependency?
Think like an architect. Prioritize security and compliance over flashiness, and you will absolutely ace the AB 100 exam. Thanks for joining me on this explainer, and keep building smart.